Hello everyone, welcome to my channel. So in this video we'll be learning about the storage classes in C. So let us start. Now first of all, what are storage classes? Now storage classes are basically used to define the scope and the lifetime of a variable. Okay, and there are four different storage classes in C, that is the automatic storage class, and for this the keyword that we use is auto. Then we have the register storage class, the keyword that is used is register. Then we have the static storage class with the keyword as static, and the external storage class whose keyword is extern. So now let us discuss about them in detail. So as I told you that storage classes help us to know about the different scopes and the lifetime of a variable. So here we are going to discuss the different scopes for different storage classes that we use in C. So first of all, we'll start with the automatic storage class or the auto storage class. So here basically we are going to define these four storage classes on the basis of these four parameters, that is their storage place, that is where exactly the variables are located, then their default value, and their scope and lifetime. Okay, so if you talk about the storage place, then for all the four storage classes the storage place is RAM, but in case of register it is register. So what does this mean? So basically, like when you're giving an input, suppose you are saying int x, so this x needs to be stored somewhere, right? So this x variable will be stored in the RAM if your storage class is auto, extern or static. But in case of register, it will be stored directly in the register of the CPU. So that is what it means, that is it is the storage location where exactly your variable is being stored. Okay, so that is your storage space. Then let us go to the default value. Now what do you mean by default value? So basically, suppose again I declare something like int x. Okay, and now I have declared this variable and some memory location has been allotted to x, but now I have not assigned any value to it. Okay, x is empty, I have not assigned any kind of value to it, but still I'm trying to print the value of x. Okay, if I say printf and then I'm trying to print the value of x, so what I'm going to get in that case is, if my storage class is auto and register, then I will get a garbage value in that case. Suppose if I have like declared x but I have not like assigned any particular value to x. Suppose if my x is 3. Okay, so if in that case if I want to print x, then my value 3 will be printed. But if I have not assigned anything to x, then x is empty, right? So in case of auto and register, in both the cases you will get a garbage value. Garbage value in the sense it is a random number that is generated by the compiler. It can be anything like 3, 4, 7, 8. So basically it is just a random number that will be given by the compiler if you don't assign any particular value to the variable. And in case of extern and static, you will get 0. Okay, so that is the difference in the default value that will be given in these four storage classes. Now next comes the scope. Okay, now in this scope, so like where the auto or where these four different kind of storage classes can be used. Now if you see, the scope here for extern is global, but in case of other three storage classes the scope is local. Now what I mean by this is, suppose my program is like hash include stdio.h. I start like this, and then before going for void main or int main, like before starting your main function, I have declared something like int x. Okay, I've declared it outside, right? So what happens is, in case of extern, I can make use of this x variable that I have declared outside my program, because the scope of extern is global. Global in the sense I can take it from outside or I can take it from anywhere in the program. But in case of auto, static and register, you can't do the same thing. Like you can't take this x value from outside the program, like into the program, because the scope of those three storage classes is local. Only the extern storage class has global scope. So only using extern you can access this value of this variable x within the main program. Now comes the lifetime. Okay, so lifetime is basically till which part of the program or the function that variable is going to be alive, you can say, or you can use it basically. So in that case, if you see for auto and register, the lifetime is same, that is within a particular function. For example, in a particular program I have declared like 2 3 functions, I have made different functions. So for each function I have to declare separately their auto or register. Okay, I cannot use the same auto function to access the variables between auto storage class to access the variables between 2 or 3 different functions. Okay, so it's like the lifetime will be within a particular function only. Suppose here I have declared a function. Okay, now this function calling I'm doing over here. So here this is my function. So I'm going to use this auto over here. Now when I use this auto in this particular function, its lifetime will be evaluated to that particular function only. It will not be outside that function. Okay, if you come outside that function, then again your variable will become a new variable, and the values will be different for storing the location. Now in case of register also, it the same thing happens, that the lifetime of the variable will be there till only till the function. Outside the function it won't be there. But in case of extern and static, the lifetime will be till the end of the program, that is from here till the end, that is including all the functions, the lifetime of the variable will be there in case of extern and static. In extern, what happens is that we can declare it anywhere in the program, and we can access the variable values from anywhere within the program. It can be from different functions also, you can access the values, but it should be within the same program. And in case of static, it will retain the value between multiple function calls. Now, as the name also suggests, that it will be static. That is, if I have declared some value, say x is equal to 5, and if I have done that like static x is equal to 5, okay, now I've made this variable as static. So in that case, what I'm going to do is the value of 5 will be the same even if I have gone through multiple function calls. That is, even if I am calling the function again and again and performing some kind of operation on it, still the value of x will remain as 5 only. It will not change once we come out of the function. Now let us see the various storage classes in detail. Let us try to solve some examples for it. So the first storage class that we're going to discuss about is auto, the automatic storage class. So for this, the keyword that we're going to use is auto. Okay, and this auto keyword is going to be applied to all the local variables, and this is called as the default storage class. Now why is this called as default storage class? Because see, sometimes what you do is you declare int a is equal to 10, right? So if you don't mention any storage class, then also the default storage class will be auto. Now if I write auto int a is equal to 10, and if I write int a is equal to 10, both of them mean the same. That means whether I mention auto storage class or not, it will be the default storage class that will be applied to my variable. Okay, and that is why it is known as the automatic variable. So now let us see some programs on this. So as you can see, this is one example program for you. So here basically I have like declared these two variables a and b with data type int, and I have assigned the values also to them. But you can see for one of them, that is for variable a, I have not mentioned any storage class, but for variable b I have mentioned the storage class as auto. Okay, and now I'm going to print both a and b. So now I'm going to see what is the difference when I mention auto and when I don't mention auto. So as you can see, for both of them I have got the output as 10 only. So what I want to convey from this is that whether you mention the auto keyword or you don't mention the auto keyword, it will be the same, because this is going to be your default storage class. Now let us see one more example. So this is my next program. Now in this, as you can see, I have made two blocks of program. This is my first block of program and this is my second block of program. So what I'm going to do is, with the help of this program, we will understand about the lifetime of the variable when we use auto storage class. So if you see in this program, um, first what I did is my auto int I is equal to 1. The first thing what I did is I have taken the data type int, and I have taken the variable I with the auto storage class, and I've assigned the value as 1. Then I'm going to enter this block. Okay, now in this again I'm going to assign the I variable, but this time I'm going to assign the value as 2. Okay, with the auto storage class, and I'm going to print this value of I. Now after that I have come out of this block, and I'm going to print the value of I once again. Now let us see what will be the output. So as you can see here, we got the output. First we got the output as 2, and then we got the output as 1. But how did we get this output first of all? So if you see here, the first thing which I did was, okay, I is equal to 1 was declared. But when I entered this block, what happened is that a new location for I is declared, that is I is equal to 2. And when I printed I got the value as 2. Right? Now as soon as I come out, and again when I say print the value of I, it won't print I as 2. It will print what is in the outer block, that is I is equal to 1. That will be printed. So with this we can understand that the lifetime of the variable when we use storage class will be only within the function. As I told you in the very start that auto and register storage classes, in both of them the lifetime of the variable is within the function. That is, you can see that as soon as I came out of this particular block, the value of I is no longer 2. Okay, so it was lifetime was only within that particular function. Now when I came out, we got the new value of I, and that new value of I was from the outer block, that is I is equal to 1. So I got the output as 1. So first I got the output as 2, then I came out of the block and I got the output as 1. So these were some examples for automatic storage class. Now let us move on to our next storage class, that is register. So in register, basically the memory allocation is done in the register of the CPU. Like in case of other storage classes, the memory allocation is done in the RAM. But in this, basically the variables are stored in the register, and the size will be same as that of the register size. And if you talk about the runtime, like it has got a faster access when compared to other variables. And basically we use register for quick access, getting the variable quickly. And one more thing about register is that we cannot get the address of the register variable when we use this kind of storage classes. So basically this register is kind of similar to auto. The only difference is that it will help to decrease the runtime of the program and make it more efficient. Okay, so now let us see one example program. So this is one example program for register. Now in this you can so in this, as you can see, we have declared one register int I. Okay, so here both are int I and int sum, both of them are having the storage class as register. And I've given a for loop over here, and I'm performing this operation inside the for loop, and my printf statement is given over here. Okay, so what I'm going to do basically over here is that first let us see the output of this. Okay, so here we got our output. So what basically happened over here is that first thing what happened is we know that our sum value is 0, and when we enter the I loop, our for loop, our I value was 0. Now our sum value is equal to sum plus I. So sum value is already allocated as 0, so now sum value will become sum plus I, that is 0 plus I. Okay, 0 plus the I value. I value is again 0, so sum will be 0, so that will be printed over here. Now in next case, when we go back to the for loop, we have incremented our I value, so I value becomes 1. Okay, now I value becomes 1, so sum is equal to sum plus I. So now my I value is 1 and sum is equal to sum plus I. What was the previous sum value? Previous sum value here is 0. So 0 plus 1, sum value will becomes 1. So 1 is printed over here. Then again when I go back to this I loop, my I value was 0, then 1. Now my I value has become 2. Okay, my I value has become 2. and 2 is less than or equal to 0, that case is true. So again we enter this for loop, and now my sum becomes sum plus I. Now what was the previous sum value? Previous sum value was 1. So sum is equal to 1 plus I value, that is 2. So sum becomes 3. So that is how I got my output as 3. So that is how when we perform this for loop I get the output as 0, 1, 3. But now you might think that I use the register storage class over here, but if I use the auto storage class, then also I'm going to get the same output. So you might be thinking that what is the difference between auto and register? So it's just about the timing, okay, the runtime of the program, like how much time it takes to actually execute it. Like suppose if you take auto, and this for example is my RAM, and this is my register. Okay, so what happens in case of auto is that first thing is that your variables I and your sum will be stored in RAM, and then what you do is the performance, like the operation that you're going to perform, that is sum is equal to sum plus I, that will be done in your register. Okay, so first what you do is you will take the 0 value, then you'll allocate the 0 value in the register, you will perform the sum operation, then again you will give back the sum value back to the RAM. Again you will increment the I value, you will give this incremented I value to the register, again the operation will be performed, and the sum value will be returned back to RAM. So this thing, this time of switching, this time will increase the runtime of the program. So when you use registered, what happens is all this is not required. Directly the variable will be stored in the register. So you can directly access the variable that is from the register itself, and here only you can perform the operations. So basically this time which is getting wasted in switching, that time can be reduced. So that is what we use register, because it will help to decrease the runtime of the program. Now let us see our next storage class, that is the static storage class. Now in this what happens is that the static variable, that is the variable which we have assigned the static storage class, that will be initialized only once. Okay, and whatever value you have initialized, that value is going to exist till the end of the program. That means it will remain static, it will not change. Okay, it will change only when the program has stopped, that is the complete execution is done. And also it will retain its value in different function calls. Okay, like when you perform multiple function calls within a single program, if you don't use static storage class, then the value of the variable changes every time you perform the function calling, and a new memory will be allocated for the variable. But when you do it with static, then the value will remain the same even during multiple function calls. Now let us see an example for it. Now let us see an example for a static storage class. So here you can see I have declared the function over here, and this is my main function, and in this I'm performing the function calling. I've called this function 3 times, which means that I want this part of the function to execute 3 times. Okay, so first let us see the output. So this is going to be our output, but how did we get this output is what we're going to discuss now. So the first thing which I did when I performed the function calling, you can see here a is equal to 1, and I have given int b as static. Okay, so I have applied the static to my variable b. So first thing what happens is that a memory location for a and b is created. Okay, now in the memory location of a I have assigned the value 1, and in case of b I have assigned the value 1. Okay, as of now both of them are having the value 1. Now when I print both a and b, I'll get a value as 1 and b value as 1. So you can see here first I got a and b value as 1. Okay, now the next step, when you see, we are going to increment the value of a and b. Okay, that is a plus plus and b plus plus, we are incrementing the value of a and b by 1. So my a value is going to become 2, and my b value will also become 2. Okay, these are my new values for a and b. Now the next moment we are coming out of the function. Okay, now we have come out of the function, again I'm performing the function calling, again I'm going to enter the function. So as soon as I come out of the function, my location for a variable is destroyed, but my b variable will remain as it is, because I had assigned the static storage class for my b variable. So it's going to remain as it is, but my int a, that is the a variable's location, is destroyed because I have just come out of the program. here you can notice one more thing, that here I have given int a is equal to 1. Now since there is nothing mentioned over there, that means the variable, that is like the variable a, is having the auto storage class. And you know that the auto storage class, the scope of the variable is only within the function. Okay, as soon as you enter outside the function, the lifetime ends. So that example also you can see over here, that as soon as we are coming out, the value of a is getting destroyed. Again, the lifetime is getting stopped over there. So now my a variable's location has been destroyed. It is completely fresh. But b location is as it is, that is 2. Now again, when I entered, a will be assigned a new location, that is 1 again, and b will remain as it is, that is b will remain 2 only. Okay, so this time when I print it, a will be 1 and b will be 2. So here you can see a is 1 and b is 2. Okay, so what happened over here is, now my new location is a will be 1 and b was as it is 2 from the previous case, because it is static, so it won't change. Now the next moment what is happening is, again when I'm seeing this, again I'm incrementing the value. When I increment the value, a value will become 2 and b value will become 3. Okay, so these are my new a and b values. But after this incrementation, I am going to come out of the function. Now as soon as I come out of the function, again my a variable's location is destroyed, but b will remain as it is. Okay, now again for the third time I am going to do the function calling. That means again I am going to enter this. Now when I enter, I'll make a new location for a with the value 1, and my b will remain as it is. Because b location was as it is, it did not change, only the variable's size got incremented, that is the value got incremented. So now my a value is 1 and b value is 3, and that will be printed over here. So you can see a is 1 and b is 3. So that is how you can use the static storage class if you want the variable value to exist till the end of the program. Now when you see, when I come out of the program, again since my 3 function calling is done, so now I can exit the program. Now as soon as I exit the program, this a location and b location, both of them will be destroyed. Now again you can take fresh values for a and b by running the program once again. But as of now, till the program was running, till that time a b value was static. Okay, so this was an example for static storage classes. Now let us move on to our next storage class, that is extern. Now from the name itself you can understand that it is something which is like external, that is you can access, when you provide this extern storage class, you can basically access the variable from any part of the program. Even if it is present in a particular function or in a particular block, you can still access its value. Also, one of the most useful feature of extern is that when you are, suppose you are having multiple files or multiple functions in your program, and you want to take the values of variables which is present in a particular file, or you want to exchange the value of variables in multiple files. So for that you can use the extern keyword. Now let us see an example for this. So this is an example program for our extern storage class. So let us see the output first. So here is our output. So what happened in the program? So first thing what I did is, here you can see I have declared the variable a with the value 10, and it is outside my main function. So what is this happening over here? This is my global variable declaration which I performed over here. Okay, this thing is my global variable declaration, and when I'm entering the main function, you can see that I'm using the extern keyword with the int a. Okay, so now the next thing what is happening over here is I'm going to print the value of a. So when I print the value of a, you can see that I took the value of a with extern keyword. Now I'm going to take this value of a. So a value I got it as 10. So extern, basically in the starting of the video I already told you that the scope for extern storage class is global scope. That is, in case of other storage classes the scope will be local. Okay, only within the program you can access the variables. But in case of extern, the scope is global. So here in the global variable declaration also you can take the variable from outside the main function. So here basically I have called the value of int a from outside the main function, and I'm going to print that value. So I got here as 10. The next thing you can see here is I'm performing a function calling. Okay, now this function calling, when I perform, I come to this function, and then when I come over here, you can see that I have assigned the value of a again separately, and I've performed the increment. Okay, and after performing the increment, I'm going to print the value of a. So when I print the value of a, this time I have got the value of a as 3. So here I got it as 3 because I didn't use extern over here. Instead, I have declared it separately int a, and then I've assigned the value, and I'm going to print that value. If again I use extern over here, then again I can take this value. Okay, take this value and I can input over here by using extern. But then I have not used extern, I have separately assigned it. So you can see that here the value of a is equal to 10 is not taken, the value of a is equal to 2 is taken. So basically this extern was only for the main function. If you want it over here, again you can assign it over there. So that is an example of extern storage class. So with this we have completed our storage classes. So if you have any doubt, you can let me know in the comment section below. So thank you for watching, and meet you in my next video.